30-06 Springfield. Adopted in 1906 after refinement of the 30-03, the U.S. Army standardized a rimless, bottlenecked 30 caliber cartridge from Springfield Armory that paired a Spitzer bullet with the M1903 rifle. Design lineage reflects a goal of flatter trajectories and safer range limits for mass training while retaining machine gun utility. U.S. industry produced it across government arsenals and commercial contractors throughout the war. The cartridge powered the M1903 and M1917 rifles, the M1 Garand, the M1941 Johnson, and a suite of Browning machine guns including the M1917 and M1919, as well as the BAR. It appeared across every U.S. theater and in Commonwealth service through Lend-Lease. Dimensions follow a rimless, bottleneck layout with an overall length near 85 mm and a 63 mm case. U.S. headstamps typically show maker and year. Wartime economy lots substituted steel jacket components when copper was tight. Ball M2 used a 152-grain flat base at roughly 2,800 feet per second, while the earlier M1 ball was a 174-grain load around 2650. Armor-piercing M2 with black tip, tracer M1 M2, and incendiary M1 rounded out the core combat families. Marines retained the heavier M1 for certain sniper tasks in the Solomons, and M2 AP demonstrated penetration around half an inch of armor steel at 100 yards in testing. Production exceeded 2 billion rounds, and alternate ball and tracer lots conserved strategic metals. It remained the American rifle and machine gun mainstay through the conflict, and later informed the 7.62 by 51 mm NATO solution to similar ballistic goals. 7.92 by 33 mm Kurz. Polte in Magdeburg developed a shortened intermediate cartridge beginning in 1938, fielded from 1942 through 1945 to support the Wehrmacht's Sturmgewehr program. The goal was controllable automatic fire from a shoulder rifle at typical infantry engagement distances without the mass and recoil of full-power 7.92 by 57 mm. It fed the Sturmgewehr 44 and the Gustloff Volkssturmgewehr, with limited use in conversions and prototypes. Infantry carried curved magazines that reflected the case geometry and taper needed for reliable feeding. A rimless, bottleneck design. The Kurz case length sits at 33 mm with overall length near 48 mm. Bullet diameter is about 8.22 mm with a nominal 240 mm twist. German headstamps followed wartime codes for maker, lot, and year. Color rings and tip markings identified tracer and special-purpose rounds. Typical loads used 8.0, 8.1 gram bullets around 685 meters per second from a 419 mm test barrel, producing energy in the vicinity of 1900 joules. Ball Maitami used an iron core to conserve lead, and tracer variants supported fire control. German output approached the high hundreds of millions of rounds, with lacquered steel cases common as brass shortages grew. The cartridge cut weight roughly a third compared to 7.92 by 57 mm, increased carried ammunition, and framed the assault rifle concept that many post-war designs would revisit. 30-03 British. The 30-03 began life in 1888 as a black powder round for the Lee Metford and moved to smokeless propellant by 1891. It served as the British and Commonwealth rifle and machine gun cartridge through 2 world wars before replacement by 7.62 by 51 mm NATO in the 1950s. Standard platforms included the Lee-Enfield rifle family, the Vickers and Bren machine guns, and a range of aircraft and anti-aircraft installations. The cartridge's broad service footprint reflected the logistics of an empire at war. It is a rimmed, tapered, bottleneck design with a case length about 56.4 mm and overall length near 78.1 mm. Head stamps and label codes carried Z for nitrocellulose propellant, while colored tip and annulus markings distinguished tracer, armor-piercing, incendiary, and observing loads. The Mark VII 174 grain Spitzer with a light nose filler produced around 2,440 feet per second. The Mark VII Z boat tail, at roughly 2,525 feet per second, extended Vickers' machine gun range. Britain produced billions of rounds across multiple marks, and wartime experience revealed trade-offs. The Mark VII's had higher pressure, and boat tail profile accelerated bore wear in rifles and some light machine guns, but it was used when the tactical need outweighed the maintenance cost. The 3003 defined Commonwealth small arms supply in both world wars and anchored training, doctrine, and industry. 6.5 by 52 mm Carcano. Italy's 6.5 by 52 mm was developed between 1889 and 1891 and adopted in March 1890. Entering service for the M1891 Carcano and its successors. Italian ordnance adopted solenoid propellant in 1896, and early production paired the cartridge with gain twist barrels before that feature was phased out. The round served in the Carcano rifle line throughout the Second World War. It also appeared with forces allied to or supplied by Italy, and later in German hands after occupation. A rimless bottleneck case measuring 52.5 mm pairs with an overall length of about 76.5 mm and a bullet diameter near 6.8 mm 0.268 inches. Military specifications set maximum average pressure around 285 MPa. Italian head stamps followed arsenal and year conventions common to the period. Typical service ball was a round nose of roughly 10.5 grams at about 700 meters per second from long rifles, with lower velocities from shorter barrels. Doctrine set rifle sights for long volley distances to capitalize on the flat shooting characteristics then desired. Italy planned to transition to a 7.35 by 51 mm successor, but wartime logistics halted the changeover. The Carcano's early embrace of small-bore ideas influenced a generation of 6.5 mm military cartridges and left a distinct footprint in European service ammunition history. 30 Carbine US. Winchester developed the .30 Carbine as part of the U.S. light rifle program, with service beginning in 1942 alongside the M1 Carbine. The design drew on .32 Winchester self-loading lineage, while optimizing powders and bullet weight for the new platform. The M1 and later M2 carbines used it widely among officers, paratroopers, reconnaissance troops, and support personnel such as machine gun, artillery, and tank crews. Allied partners received it under Lend-Lease, and it continued in French service into post-war conflicts. A rimless, straight-walled case of about 1.290 inches pairs, with an overall length around 1.680 inches. Early manufacture turned down 32 WSL cases. The first 100,000 rounds carried head stamps reading 30 SL. Standard small rifle primers were specified for mass production. The typical 110-grain full metal jacket load produced roughly 1,990 feet per second from an 18-inch barrel. Wartime types included M1 ball, M27 tracer, M6 grenade blanks, M13 dummies, and tin-plated high-pressure test cartridges. Packaging evolved from 45-round to 50-round cartons, and sealed spam cans appeared later in the war as shipping and storage practices matured. It was intended as a light rifle round rather than a full-power infantry cartridge. Experience placed decisive effects at short distances, which matched the roles for which the carbine was issued and shaped later doctrine regarding automatic fire with the M2. 9 by 19 mm Parabellum. Georg Luger created the 9 by 19 mm in 1901 by necking up his 7.65 by 21 mm design. Germany adopted it first for naval service in 1904, and then the Army in 1908, and it spread rapidly with wartime production. It became known interchangeably as 9 mm Luger, 9 by 19 Parabellum, and 9 mm NATO in later contexts. During the Second World War, it served as the principal pistol and submachine gun cartridge for Germany and many other nations. It appeared in Lugers, P-38s, and a broad catalog of SMGs across Europe. The cartridge is rimless and tapered, with a 19 mm case, overall length near 29.7 mm, and head spacing on the case mouth. German wartime headstamps used letter codes for factories, year and lot, tracer, incendiary, and economy bullets such as the 08ME Iron Core and AO8 SES-E. Sintered iron variants addressed supply and operational needs. Typical bullet weights ranged from 115 to 124 grains, with velocities around 1,000 to 1,300 feet per second, depending on loading and barrel length. The combination of manageable recoil, compact dimensions, and compatibility with both pistols and submachine guns maintained its appeal. Manufacture occurred in dozens of countries, and later standardization simplified logistics for alliances. Feedback from military and police users continued to shape load development, ensuring that the cartridge remained central to sidearm and SMG roles long after the war. 50 Browning machine gun. The 50 Browning machine gun, or 12.7 by 99 mm, emerged from late First World War and immediate post-war work at Winchester and Frankfurt Arsenal, entering U.S. service in 1921 with the Browning water-cooled gun. By the Second World War, it was fully integrated across ground, vehicle, and aircraft mounts. Its primary wartime host was the Browning M2 in heavy barrel ground versions and light barrel aircraft configurations. The caliber served anti-aircraft, anti-vehicle, and general-purpose roles, and it became a signature feature of Allied aircraft armament. A rimless, bottleneck case about 99.3 mm long sits under an overall length near 138.4 mm with a bullet diameter around 12.98 mm. Headstamps reflected the U.S. maker and year, and belts were assembled with pull-out and push-through metallic links depending on the application. Representative heavy ballistics include 647 grain bullets at roughly 3,000 feet per second and 750 grain projectiles near 2,820 feet per second, generating muzzle energies an order of magnitude beyond rifle cartridges. Armor-piercing, incendiary, and combined API loadings provided effects against thin armor, aircraft, and materiel, with penetration data around an inch of rolled plate at short to medium distance. Production included ball, tracer, a P incendiary, a PI, and observing types, as well as blanks and drill. The cartridge later migrated to anti-material rifles and long-range rolls while remaining in machine gun service, and subsequent innovations such as polymer-linked belts pursued weight savings without changing form factor. 7.5 by 54 mm French. French ordnance at Manufacture d'Armes de Saint-Étienne created a new 7.5 mm cartridge in 1924 by shortening the earlier 7.5 by 57 to avoid confusion with German 7.92 by 57 mm. The final 54 mm case, standardized as 7.5 by 54 mm MAS 1924-29, entered service in 1929 and replaced the 8 by 50 MMR Lebel. It armed the MAS-36 rifle and the FM-2429 light machine gun in the Second World War, along with Ribel, MAC, and Darn aircraft guns. Post-war service included MAS-49 and 49-56 rifles, the AA-52 and the FRF-1 sniper platform. A rimless, bottleneck design with a 54mm case and overall length about 76mm carries a bullet diameter near 309 inch, with case capacity around 3.76. French military headstamps followed national styles. Many cartridges were corrosive and Berdon primed, and an internal annular groove in some cases discouraged reloading. Ball loads included the lighter ballistic at 9 grams, around 850 meters per second, and the heavier ballistics at about 12.35 grams, near 694 meters per second. Armor-piercing, tracer, a P-tracer, incendiary, gallery, and blank types appeared in wartime catalogs. It saw wide post-war combat use in Indochina and Algeria. The cartridge's ballistics sit close to the later 7.62 by 51mm NATO, and its long service life across rifles and machine guns demonstrates how a carefully balanced full-power round could span multiple roles without constant redesign. 7.7 by 58mm Arisaka. Japan developed the 7.7 by 58mm during the interwar years and formally adopted the rimless Type 99 ball in 1940 to replace the earlier 6.5 by 50mm semi-rimmed round. The program sought heavier projectiles and greater short-to-medium range effect across rifles and machine guns. It chambered the Type 99 rifle and light machine guns, and also fed the Type 92 heavy machine gun and Type 97 tank and vehicle guns. The shift reflected a broader Imperial Japanese Army move to a full-power class, similar to 30-03 British and 8mm Mauser. The rimless, bottleneck case measures about 57.8mm with overall length near 79.6mm, derived from the 8 by 57 lineage, with wartime standardization on a roughly 12.1mm rim diameter. Headstamps carried arsenal and date information, and colored rings indicated special loads. Ball, armor-piercing, tracer, incendiary, and high-explosive projectiles were produced, each with color codes for identification. Bullet weights ranged from the mid-150s for tracer to over 200 grains in certain heavy machine gun loadings, with velocities spanning roughly 2,400 to 2,700 feet per second, depending on platform and role. Standardization simplified supply across small arms and support weapons, even as older semi-rimmed stocks remained in niche uses. The 7.7mm provided Japan with a true full-power service cartridge during the war and maintained battlefield parity with peer nations in that category. 7.9 2 by 57mm Mauser. Germany redesigned the M88 7.9mm cartridge to the S-bore 7.92 by 57mm in 1903-1905, creating the round that would serve as the primary German rifle and machine gun cartridge in both World Wars. The Rifle Testing Commission coordinated the changes, and German industry executed production at national scale. It powered the Carabiner 98K rifle and the MG34 and MG42, while Allied and occupied plants also produced it. Britain fielded it in the Besa tank machine gun, making it an unusual case of a single cartridge in both Axis and Allied inventories. The design is rimless and bottlenecked with a 57mm case and overall length near 82mm, firing an 8.22mm bullet and typically using a 1/240mm twist. German headstamps encoded maker, lot, and year. Primer annulus colors differentiated load families, such as green for SS in many lots and blue for SI in others. The SS Patrone 12.8 gram boat tail became the 1930s standard for long-range machine gun fire at roughly 760 meters per second from a 600mm barrel. The SME mild steel core round introduced in 1940 conserved lead and largely displaced SS by 1942-43. Germany shifted heavily to steel cases by late war, as brass shortages deepened. Packaging and labels indicated rifle or machine gun emphasis. The cartridge's reach, versatility, and manufacturing ecosystem made it one of the defining military rounds of the 20th century and a direct ancestor of many later designs. We appreciate you spending time watching our videos. If this one was entertaining, a thumbs up and a share with your fellow firearm enthusiasts goes a long way. Please subscribe to the channel so you don't miss future content.